Module 2.1. As a reminder, it's recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 2.1. What is random sampling and why is it important? If looking at the entire population is sometimes impossible, how can we learn about it? One of our primary goals in this course is to learn how to use the information in a sample to learn about a population. Don't forget, as we move through the material, that the population is the group that you would really like to learn about. If we have population data, we can examine it directly. If we are unable to survey or collect information from the entire population, we call the collection a census. The purpose of selecting a sample is to learn about the whole population when the whole population is unobtainable. Definition. Statistical inference is the process of using the information contained in sample data to draw conclusions about what is happening in a population. Statistical inference will provide methods to account for sampling error. Definition. Sampling error occurs when the statistic is not equal to the parameter due to looking at a sample instead of a population. We will discuss sampling error in depth later in the course. The first step to selecting a sample is to have a clearly defined population. Ideally, when selecting a sample, we would like a sample that has characteristics similar to the population's characteristics. One way to select a sample that is likely to have characteristics similar to those in the population is to select the sample randomly. Definition. A simple random sample, usually abbreviated SRS, occurs when every group of size n has the same chance of being chosen. It's important to note here that the definition of a random sample says nothing about the responses that people give. A simple random sample is solely defined by how the people or other elements of interest are selected to be in the sample. In the field of statistics, random samples are very important. We need random samples to be able to make conclusions about the population from sample data. In later modules, we'll talk about sampling variability, sampling distributions, and why random samples are important. Using the definition of a simple random sample, indicate whether the following statements are true or false and tell why. For each situation, ask yourself, does everyone of interest have the same chance of being selected in the sample? We're going to do the first one together. I decided to take a sample of students at UK. To take my sample, I stand in the middle of campus and interview the students who walk by me. My sample is a simple random sample. This statement is false. Not all UK students have a chance to be in my sample. For example, students who take online courses or students who were not on campus that day could not be in my sample. I decided to take a sample of students at UK. I obtain a list of all student ID numbers and use a random number generator, which gives every group of IDs the same chance of selection, to pick 100 ID numbers. I then have those students take my survey. My sample is a simple random sample. This statement is true. All students have the same chance to be in the sample, and all groups of 100 have the same chance. Also, all groups of any size would have the same chance. I want to take a sample of people who live in Kentucky. I use a random number generator to pick addresses of 50 households from my hometown. My sample is a simple random sample. This statement is false. People who live in Kentucky but not in your hometown do not have a chance to be in the sample. I want to know how UK students feel about euthanasia. I know that students enrolled in the College of Public Health are very diverse and reflect the diversity on campus. I randomly select 150 students from the College of Public Health. My sample is a simple random sample. This statement is also false. Students who are not in the College of Public Health will not have the opportunity to be in the sample. How can we select a simple random sample? The goal is to select our sample from the population randomly. We first need to find the sampling frame. The sampling frame consists of a list of the subjects in the population. You can think of it as a menu of subjects. Previously, we saw this simple random sample of size n consists of n individuals from the population, chosen in such a way that every set of n individuals has an equal chance to be in the sample selected. In practice, people use random numbers generated by a computer or calculator to choose samples. If you don't have technology handy, you can use a random number table. The website, located at the link in the script, gives an example of a random number table. Let's look at how to select a simple random sample. First, label. Give each member in the population a numeric label of the same length. 2. Generate random numbers. Your sample contains the individuals whose labels you find. For example, suppose that we have a class of 20 students and would like to take a simple random sample of 5 students. We'll start by giving each student a label consisting of the numbers 1 through 20. Below are each of the 20 students with their labels. Notice that each label has length 2. So for example, looking at the number 1, we label that one 0, 1. Next, to take a random sample of 5, we can visit a website which will generate the random numbers for us. An example of one is given here. We will need to generate one set of 5 integers where the integers are between 1 and 20. Below is some sample output. Based on the output, we would select the following. Notice here, we have selected the subjects with labels 8, 10, 11, 16, and 20. This will result in 5 students in the sample. You can try the website on your own to see which sample you would get. Are there other types of random samples? There are many other types of random samples. For all random samples, the goal is to obtain a sample that accurately represents the population of interest. Watch the video located in the script from the Pew Research Center. There are also several good websites which summarize different types of samples, one of which can be found at the link given here and in the scripts. This website will summarize both random and non-random samples. Pause the video and use the second link to find the definitions of each of the following types of samples. Let's look at an example which will illustrate the different types. Suppose I'm interested in the temperature of rooms in an office building. The building has 5 floors, and each floor has 10 offices for a total of 50 rooms. I would like to sample 20 offices to measure room temperature. Systematic sampling would do the following. Each room in the building will be labeled from 1 to 50. Then dividing the population size by the sample size would give 50 divided by 20 equals 2.5. Therefore, for systematic sampling, k would be equal to 2. Systematic sampling says to choose a random number between 1 and k. Then, since k is equal to 2, select every other room. For example, if the randomly selected number is 2, then the sample would consist of rooms 2, 4, 6, 8, all the way up to 50. Cluster sampling would break the office building into 5 clusters. Each cluster would be a floor of the building. Since I need a sample of 20 rooms, cluster sampling says to randomly choose 2 of the 5 floors and use the rooms in the 2 selected floors as the sample. Stratified sampling, on the other hand, would still break the office into 5 strata, where each strata is a floor of the building. Since I need a sample of 20 rooms, stratified sampling says to randomly select 4 rooms from each of the 5 floors to get a sample of 20. To summarize the difference between cluster and stratified sampling, in cluster sampling, we select whole clusters, whereas in stratified sampling, we select some from each of the strata. What do we do when simple random sampling is not possible? While a random sample is ideal, often it isn't feasible. Notice that to take a random sample, we need a list of every member of the population. A list of the entire population may not be available. Another potential problem is that it may be impossible or too difficult to contact all members of the population. Sometimes the conclusions cannot be made about the population of interest. Instead, the conclusions can only be made about a more feasible group from which you can select a sample. As a result, generalizations of the conclusions are limited to the population from which the sample was obtained. When a sample is not selected randomly, we risk collecting a sample that does not reflect the population. A biased sample will systematically miss portions of the population. If the sample does not reflect the population, then we will not be able to make good statistical inference. When this occurs, we call it sampling bias. Definition. Sampling bias occurs when a non-random sample does not adequately reflect the characteristics of the population and results in poor inference. This results in an over or underestimation of the parameter. Non-random samples can have many issues. Let's consider some different non-random samples and identify some issues they may have. Suppose you want to estimate the average number of hours that students at UK spend studying each week. We will critique each method of sampling. Take a moment and read the 3 different methods. Method A. Go to the William T. Young Library and ask all students there how many hours they study each week. In this scenario, sampling is based on a related variable, i.e. studying is related to being at the library. This is an issue because students at the library are probably already studying. In this case, if we were trying to estimate the average number of hours, we would be excluding those people who study 0 hours. B. Tweet asking all UK students how many hours they study each week and use all the responses you get. In this scenario, we're relying on the information from volunteers. This is also known as a volunteer study. Samples comprised of volunteers are biased. Volunteers tend to be people who feel strongly one way or another about a topic. Usually people without strong feelings do not volunteer. Stand outside the student center and ask everyone going in how many hours a week they study. In this scenario, we have a convenience sample. Convenience samples contain bias because they often miss parts of the population. So in this scenario, we're likely to miss students that are in online programs. What other types of errors may occur when taking a sample? Does taking a random sample take care of all bias? No. Even with a random sample, we still run the risk of having a biased sample. Other things that can cause bias include the following. People selected in the sample chose not to participate, question wording, inaccurate responses, undercoverage, many other possibilities. We always want to examine the specifics of each study. In practice, think hard about potential sources of sampling bias and try your best to avoid them. Recall that sampling error occurs when the statistic is not equal to the parameter due to looking at a sample instead of a population. This type of error is expected, and we have statistical methods for estimating sampling error. The more problematic type of error is the non-sampling error. Definition. Non-sampling error is an umbrella term for any other type of error besides sampling error. These types of errors are not limited to when we look at samples, but also apply to when we look at whole population. There are 2 types of non-sampling error that we will consider below, but there are many other types that are possible. Visit the website listed here and in the script, which describes some types of non-sampling error. Take the time to read through the entire site. Definition. Non-response error occurs when we can't question people who are eligible to take the survey. This usually occurs when people are asked to take the survey but refuse. They may refuse to take the survey for different reasons. Questions that make people uncomfortable are more likely to cause non-response error. things like drug use, sexual habits, finances, and etc. Definition. Coverage error occurs from not allowing all members of the population to have an equal chance to be in the survey. Notice, by definition, a simple random sample cannot have coverage error. As we move forward in the course, keep in mind that our goal is to learn ways to use the information in a sample to learn about a population of interest. We need to be cautious when we do this, as not all samples will provide proper statistical inference. We need a sample that is randomly selected and one that has accounted for the potential of non-sampling error.